Okay, we're going over directive inverse variation, and I'm going to make it pretty quick. We're going to go through a lot of the technical, the mathematical work, but direct variation is when increasing one thing leads to an increase in the other, and inverse is increasing one thing leads to a decrease in the other. And I'll show you what that means real quickly. If you look at number one, it says the hours you work. As you increase the hours you work, you also increase your pay. So number one is direct variation. Number two, I'll write it down. So number one is direct. Number two, the faster you drive, the less your travel time. So as you increase speed, you decrease time traveled. So this would be an example of inverse variation. And number three, the length of a side of a square. So as you increase the length of each side, what happens to the perimeter? The perimeter also increases, therefore this is direct. And your GPA, so as you increase your GPA, well actually, I have that backwards. Your GPA compared to the hours that you watch TV. Basically, if you increase the number of hours that you watch TV, you should decrease your GPA. You know, it might not be true exactly, but you get the idea. So as you increase your hours you watch TV, your GPA will probably decrease. So this is an inverse variation problem. So that's the basics right there. Here is what you really need to know. You'll see these two statements, varies directly, y varies directly as x, or y is directly proportional to x. They mean the same thing. When you see that, you are going to write this right here. All right? That is something you have to be very cognizant of. When you have a direct variation statement, you are going to write y equals kx. The y and the x are variables. The k is some constant. So we're talking. Sorry. A good way to think about that is, if x were your speed, then y would be your distance traveled. As you increase your speed, your distance traveled also increases. So k, we have to find some k value. It's called the constant of variation or the constant of proportionality. It's just a value that's true for every y and x. It's basically the slope of a line. If you think of it, it's always constant. It's the same thing. It's more complicated than that, but I'll tell you that when I see you in class. All right, so here's the example that you really need to know how to do. You are going to see a statement that looks like this. If y varies directly with x and at y equals 12 when x equals 2, find the y value when x equals 8. And this is the process you're going to use for all of these. You're going to first write a variation statement. It says y varies directly, whoops, I missed there, with x. You're going to write y equals kx. Don't forget that k. You're always going to stick that in there. And direct variation is a multiplication. That's all you have to do. Then you're going to plug in values that you know. We know that y is 12 when x is 2. So we're going to put in a 12 for y and a 2 for x from the statement right here. Our goal here is to find k. This is step 3. So once we plug those in, we're going to find k. That's just divide both sides by 2. You get k is 6. All right. And once you find k, then you go to step 4, which is rewrite the original equation with a k value. So y equals kx is now going to be y equals 6x. Now we've just found a general equation that will work for everything we can possibly think of for this situation. And once you do that, step 5 is pretty easy. Solve for the missing variable in the second situation. What that means is the second situation is find y when x equals 8. So we want to find the y when x equals 8. We're going to basically plug in the 8 for x into this equation. We're going to leave the 6 alone, and the math gets us 48. And that's the answer. So these steps will work for all these problems. First, you're going to write the statement. It's always y equals kx for a direct variation, unless I say something different here, which I'll show you later on. Then you're going to plug in values that you can work with to find k. Once you find k, you're going to rewrite the original statement from your first step, and you're going to plug in the missing either x or y, whatever you know, and you're going to find the other value with algebra. So it's a lot of algebra skills. So we'll go a little quicker on the next ones. You can pause this video and slow down. So this is very much the same thing. We'll go slide by slide. It'll go a little faster. It says y varies directly as x and y equals 10 as x equals 2.4. Find x when y is 15. So if you're looking at the PowerPoint on your own, this is the point where you'll hit the next slide. The next slide will have some of the work on it. So the first thing you should be doing is writing an equation. Y varies directly as x should lead us to y equals kx. So that would be this step right here. Then the next thing you should do, plug in what you know. You know y is 10, so y becomes 10. You know x is 2.4, so x is 2.4. You solve this with division. Divide 2.4, you will get k is 4.2. Then we're on to step 3. So step 3 is, step 4. Now that we've found the k value, now we're going to plug it back into this original equation right there. So y equals 4.2x. And now that we have a generalized equation for this whole situation, we can plug in the y value of 15 right there and use it to find x. So 15 equals 4.2x. We're just rewriting that equation. And you should be able to solve this with division. Divide by 4.2 and you get x equals 3.6. All right, this is a big, long problem just to show you how it could look. It says Prezzaloid's disdain for someone is directly proportional to the square of the number of selfies that they take. So you have to read that very carefully. Key here is directly proportional to. That means it's a y equals k blah, blah, blah. You know it's y equals k times. And we're going to multiply. Now this says the square of the number of selfies, so we're not just going to say x this time, we're actually going to say x squared. You just put down whatever is written there. So that's the general equation we're going to be writing. We'll use different letters in the future, but we'll get to that in the next slide. So it says he currently knows a lad that has taken 10 selfies. His hatred level is at a 300. That's my disdain. How will he feel about someone who takes 10 selfies? If his hatred gets to 30,000, he will put a bug in your hair. How many selfies can you take? So if you look, I used instead of y and x, d for disdain, s for selfies. So d equals ks squared is what I just said. That's step 1. Step 2 is going to be plugging in numbers for d and s from the original. So he currently knows a lad that has taken 10 selfies. So that's your s value of 10. His hatred level is at a 300. That's your d value. So we have 300 equals k times 10 squared. In solving this, you square the 10, you get 100. Divide by 100, you get 3. I'm not going to go through the process. You should be able to do that. But you're going to solve this and get k is 3. And now that we know k is 3, we should rewrite the original equation by putting in that 3. So k is 3, therefore d equals ks squared becomes d equals 3s squared. Now we have a general equation. We can plug in the last value and figure out what it is that we need to know. Okay, it says let's see here. His hatred level gets to 30,000. Okay, he will put a bug in your hair. How many selfies can you take? So we're going to plug in a 30,000 for our disdain, our d value, and we're just going to solve this. You're going to divide by 3, and you're going to square root. And when you do that, you'll get 100. So you can take 100 selfies before I reach that threshold of 30,000 disdain units or whatever. This is a made-up problem. So there you go. Then we have inverse variation. It's the same thing, except the way we write our equation this time is k divided by x instead of k times x. That's it. Everything else works the exact same. So we're going to be utilizing this in the future slides. So here's our first example. I've written it all out. Not very nice and neat. Y varies inversely. This is the statement you have to pick up on. So we should be writing right here y equals k over x. Now if this said x squared, we'd put an x squared here. If this said inversely as x minus 1, we'd be writing divided by x minus 1. So just read carefully. All right, so then we're going to do what we did before. I'm not going to really elaborate too hard on this, but here's the key point here. It says x is 18 when y is 6, so here's y is 6, here's x is 18. That finds us k is 108. Once we find k is 108, we put it back here. There's your new equation. And then we're looking for the situation, what is y when x is 8? So we go to this equation, we replace the x with an 8, and we will get 13.5. So you might need to slow down and work through this on your own, but here's all the work that you're going to be doing. Look it over, ask me if you have any questions. All right, example 2, inversely as the square root of x. Got to read that carefully. Ooh, sloppy. All right, so we're going to do the square root of x this time. So it's going to be inverse, so it's going to be division. So it's y equals k over x, but a square root, so square root of x. And I'll show what that looks like. And this is a tricky part. It says if f of 9 equals 18, find x when f of x equals 10. You just have to think about what letter that represents and what letter that represents. And here's where I'm getting with that. So the first thing is we do y equals inverse is k over, so there's k over the square root of x. That's your equation. Now if I say f of 9 is 18, that means x is 9, y is 18. Input of 9, output of 18. So what's that mean? In this equation, this y is going to become 18, this x is going to be 9. And we're eventually going to find out when f of x equals 10. So what that looks like, 18 equals k over radical 9. Doing the math, 54 is your k value. So we rewrite this equation by putting a 54 in for k. All right, and now that we've done that, it says find x when f of x equals 10. So we are simply going to put in, we don't know x, we know the output is 10, so we know the y value, so the 10 will go right here. This is going to be turned into a 10, and then we're going to solve that and have our answer. So right here again, here's where I put in the 10 for y. 10 equals 54 over radical x. You just need to know how to solve it. One clear denominator, that means multiply both sides by radical x. Okay, you'll get here. You'll get here, I should say. 2, divide by 10, so you're going to divide out that 10, you'll get 5.4 on the right side. And 3 square both sides, and you'll get 29.16. It's algebra, algebra, algebra. All right, one more. We have joint variation. Joint variation is just a combination of direct and inverse. So I say y varies directly as this, so that should mean k times that. And inversely as the cube of m, so that means divided by. That's all it means. And if you look down here, I have the actual equation. This says y varies directly as x minus 2 squared, because it's multiplication of the k, and inversely, so at the same time I'm going to put it over m to the third power. That's that statement written out right there. That's a combination. That's all joint variation is. All right, and if x is 4, then m is 2, then y is 1.75. You're going to plug in 4 for x, 2 for m right there, and 1.75 for y. And then it says find the value of x if y is this and m is this. So at the very end, you are going to be plugging into the y value, and you're going to be plugging into the m value. So you have to do a lot of algebra to get this x out of there. And I'm not going to go through the problem. I want you to try it on your own, but I do say here you should end up with a k value of 3.5 to start with. So it should be 3.5 times x minus 2 squared over m cubed. And the final answer should be either 7 or negative 3. Because you're going to get to a point where you have to get rid of this square. When you square root to solve an equation, you'll get a plus or minus. All right? So you'll get a plus 5 or a minus 5 at one point or another. And it'll solve two different equations. That's why we have two different answers here. So see if you can figure that out. Come up with any questions you have. Good luck. We're going to do a lot of work on this. It's just algebra. You just have to understand what this notation means. So look over this PowerPoint again. Hopefully it helps you. All right, take care, and I'll see you soon.